We'll just go through some trig word problems here to get a feel of how to do these. All these problems come down to drawing triangles and trying to make sense of them. It says two forestry lookouts are posted 150 miles apart. The northern lookout spots a fire at an angle of 38 degrees from the southern lookout, meaning there's a forestry post here. These are two lookouts, and I'm not going to draw them super well, but there's lookout 1 and there's lookout 2. One's to the north, one's to the south. They are 150 miles apart, so from here to here is 150 miles. The northern one sees a nice little fire out here. This is my big fire. I'll even throw in some other colors to make it realistic. Yeah, you're feeling the heat now. Good, there's my fire. The northern one sees this fire at an angle of 38 degrees from the southern one, meaning this angle here is 38 degrees. The southern sees it at 55 degrees. So this angle here is 55 degrees. The question is, how far is the fire from each lookout? So we're really going to try and find this length x and this length y. This is not a right triangle, so we can't use basic sine, cosine, tangent, but we can still use law of sines and law of cosines. If this is 55 and 38, I can find my third angle by doing 180 minus 55 minus 38. Close, computer. You were close. I'm really good at breaking this thing, so let me pause and fix it. Okay, should be all better now. If I do 180 minus 55 minus 38, that comes out to 87 degrees. So I know that this right here is 87 degrees. Now I have an angle side pair. I know that this angle and this side, since I have both of those values, I can do the law of sines. So I'll start by finding side x, the northern part. If I do sine 87 over 150, and set that equal to sine 55 over x. Well, I do my cross multiplying and dividing, and I'll know that x equals sine of 55 times 150 divided by the sine of 87. Just plug that into my calculator. Make sure that you are in degrees and not radians. Every time I restart my calculator, I have to check that. Yours probably shouldn't have to. Sine of 55 times 150 divided by the sine of 87. The distance is 123 miles. Then we do the same thing for the other one. We can't use the Pythagorean theorem to find side y because we don't have a right triangle, so we would just set the same sort of proportion, however. Sine of 87 over 150 is going to equal the sine of 38 over y. So I'd do sine 38 times 150 divided by sine 87. And we get 153 miles. This is actually how this works. This is how these people do this when they're on these lookouts at those little ranger stations on top of hills and mountains. They have to use trig to find where these locations are, and then they can send people to where they have to go based on the trig they use and the maps they have. Next one, you were standing 200 feet from the base of a building. It's always very helpful just to draw these stupid little pictures. So here are you, and here's the base of the building, and right now it looks like you're about half the size of the building, so way to go, you're really tall. The angle of elevation between the ground and the top of the and the top of the building from where you're standing is 73.6 degrees. Angle of elevation means this angle here. This is 73.6 degrees. You are 200 feet from the base, so we know this is 200. The question is, how tall is the base? Well, this is a right triangle. Since I do have a right triangle, I can just do basic sine, cosine, tangent. Now, I also could do the law of sines if I really wanted to, or law of cosines. Those are always options. I mean, I could find this angle here, because this angle up here is going to be 16.4, and with that 16.4, I could do the law of sines. But because I have a right triangle, I can just do regular trig. This is the opposite, and this is the adjacent from my 73.6. So the tangent of 73.6 is going to be the opposite over adjacent, or the height divided by 200. So I do 200 times the tangent of 73.6. And we get 679 feet. So based on my picture, you're about 330 feet tall. That's how tall the building is using trig. So it's very nice to actually measure the height of something without actually knowing how high it is, like without actually scaling the height or trying to drop a tape measure from the top or something. If you want to do this with law of sines, and you don't have to, but some people like to just do everything law of sines because it works, you would do the sine of 16.4 over 200. I had to calculate that 16.4. I had to find that, and that equals the sine of 73.6 over h. And I'll solve that real quick. That'd be sine of 73.6 times 200 divided by the sine of 16.4. And we get our 679.541. We get the same exact thing. Beautiful. Next. You're standing 50 feet from that tree over there, and you're 6 feet tall. The angle of elevation from your eye to the top of the tree is 64.4 degrees. So here's our tree. Here's you. You are 6 feet tall. And from your eye to the top of the tree, it was 64.4 degrees. We are trying to find this whole height h. But right now, we can just measure this height right here. And then take that and add 6 to it, because that has to account for the 6 feet tall that we are over here. How far are we from the tree? We are 50 feet from the tree, so there's a 50 over here. Again, I can do this with a right triangle trig or sine, law of sines and cosines. Doesn't really matter. I'm going to find this, I'm going to call this h1, since it's the short height. Sine of 64.4 is equal to, I'm sorry, I want tangent actually, I'm doing opposite over adjacent. The tangent of 64.4 is opposite over adjacent. So I'm going to do 50 times the tangent of 64.4, and then add on that extra 6, and that equals my total height. $110.35. Again, it's really nice to know the height of something without trying to actually measure it, because measuring a tree from the top of it to the bottom would be very hard, because you wouldn't be able to get a straight line, because the tree's going to warp and curve and have branches and trunks and things, but the math and the trig can take care of it for you. This is actually the most useful problem. This is really the one that covers everything. Over here, we've got this big snow-capped mountain. I'll put a little line of blue here, and above it is snow, and we'll throw some brown in there in the bottom to make it look all good and earthy. Yeah, a lot of stuff going on. There's a tree line somewhere. You can't draw any trees above the tree line. Nice little mountain there. Mount something, I don't know. And you're way out here, and you're going to measure how tall that mountain is. Well, you definitely can't measure the top of the mountain by trying to, track a ruler up there or something. And even measuring your distance to the mountain is tough to do because you don't actually know where the center of the mountain is. And measuring to the base of the mountain doesn't really help you because you still have to find all this space in between you have to cover. So trying to measure from yourself to the mountain isn't very helpful. Instead, what you do is you stand somewhere. We've got our protractor and a tape measure. We measure the angle of elevation from the ground to the top of the mountain is 20.1 degrees. So from here to here, this angle is 20.1 degrees. Then we step 200 feet closer. So we walk 200 feet closer, and my picture is going to be extremely inaccurate, but don't worry about it. This distance here is 200 feet, and this angle was 20.3 degrees. And armed with just those three measurements, 2 angles from the ground and a distance from one to the other, we can try and find this height h. the height of that mountain. Well, we're going to have to use some trig to find some other things. So let's just start with whatever we can work with and find whatever we need. If this angle here is 20.3, if that's 20.3, then this other side, they have to be supplementary out to 180. This is going to be 159.7. That's 159.7 degrees. And then I can take this angle and find this angle. That little tiny twist of an angle right in there is going to be, I'll have to do some calculating. It's probably like 0.2 or something. In fact, I think it is 0.2. 180 minus 159.7 minus 20.1 is 0.2. So this little angle in here is 0.2 degrees. I know that this here is 90 degrees, so I could find this angle if I wanted to, and I could find these other angles. But let's see if we have enough now to make some sense of this. Yeah. We're going to find this length here. I'm going to call it x. This big, long length there. And now that I have a bunch of known angle measures and sides, I can do this using the law of sines. So if I take the 0.2 degrees and the 200 feet, there's an angle side pair. So know that the sine of 0.2 over 200 is going to equal, and now I can do the 159.7, the sine of 159.7 over x. I solved that for x, so x is going to equal the sine of 159.7 divided by 200, times 200. Divided by the sine of 0.2. Let's check to make sure that all looks okay. I think that looks fine. And we get 19,877. So this distance here is 19,877 feet. It's 19,000 feet. Well, we can assume that mountain is going to be substantially shorter, but we'll have to find just how much shorter. Now I can think about this big triangle here. And me drawing my picture of my mountain probably made all this harder to see, but whatever. Now I've got this big triangle here, that yellow triangle. I have an angle here and a side here, so I want to find this side H, knowing that I have a right triangle. So now I can use a regular trig. I'm working with the opposite and the hypotenuse, so I'm doing sine. I have the sine of 20.1 degrees is equal to the opposite over the hypotenuse, 19,877. So 19,877 times the sine of 20.1 is going to equal our height. And it's 6,831 feet tall. Now I hope you realize what an accomplishment this is. You can measure the height of any object just by getting a few precise measurements of a protractor and taking a few steps. Without actually climbing the mountain or seeing how big it is or comparing it to something, you can see how much higher the base of the mountain is above where you're standing. There might be some other elevation change in between. But from this point here, from that point there, the mountain climbs 6,831 feet. All of these trig problems are really just drawing pictures and playing with puzzles and finding whatever you need to know. I mean, you could have done it by finding this angle here and this length here. I'll call it y. There's a bunch of ways to solve this problem, but ultimately you're trying to get to a right triangle. Hope that was helpful. Thank you.